Hello, I love to draw, so I had fun designing our mission patch. You can see it here on our shirts. It shows our mascot, the bulldog, on Mars with the moon and Earth in the background, and our American flag to show that we are leading the way to Mars.
We've been working very hard the past few weeks on researching different types of radiation and their effects on the human body, as well as designing our helmet to protect astronauts as they travel into space.
We've learned about all types of radiation like electromagnetic radiation, radio waves, X-rays, gamma rays, and solar flares that release ionized particles. Astronauts need protection from protons with heavier ions. It is dangerous for astronauts to go into space.
Here on Earth, we have radiation protection from our atmosphere and magnetic field. However, when the astronauts leave our planet, they have to go through the Van Allen belts, which are zones full of charged particles of radiation, such as ionized particles.
Once the astronauts land on the moon, there is no atmosphere and only a weak magnetic field, and Mars only has a thin layer of carbon dioxide and a magnetosphere which interacts with solar wind. So they will experience much more radiation once they leave Earth. The radiation in space is more dangerous because of the heavy ions and charged particles traveling the speed of light.
It takes 6 months to get to Mars, and there are different gravity fields that the astronauts have to go through. They have to endure different types of radiation, like gamma rays, X-rays, alpha, and beta radiation. Our mission was to use our research to make a helmet suitable for space exploration during transport. Besides providing radiation shielding, the helmet had to be wearable and comfortable so the astronauts could work and sleep in it. We also needed to consider adding more fabric to protect the astronauts' bone marrow production sites in their hips, pelvis, and shoulders, as well as protect the lower GI tract.
After researching a variety of radiation shielding materials, we think we have come up with a good helmet design that offers radiation shielding and contains low mass materials that won't be too difficult to put on. Our helmet will weigh around 27 pounds or 37 with the body armor, and the aerial density is 8.5 grams per square centimeter.
Our helmet design is inspired by a product called Dimron, made by Radiation Shield Technologies. Dimron is a flexible, lower density, metal embedded polyethylene and a PVC polymer fused between layers of a woven fabric. Using laminated sheets can greatly reduce gamma radiation. Dimron offers 70% high energy beta radiation and 50% gamma shielding. It can be used around the helmet and as a body shield, covering sensitive bone marrow locations in the human body, weighing only 7 pounds for an entire suit.
At first we thought aluminum would be a good material, but due to the hazards of secondary radiation, we decided to take aluminum out of the helmet and add in a layer of polyethylene, which is hydrogen-based and provides 50% better solar flare shielding and 15% better cosmic ray shielding than aluminum. And we also are adding a layer of silicone rubber, another hydrogen-based compound. It has strong gamma ray shielding properties.
A layer of composite metal foam will be under the silicone rubber. It reassembles a steel sponge made of metal with gas blown into it. It blocks gamma rays, X-rays, and neutron radiation. Polyurethane foam will be the inner layer. This material is found inside motorcycle helmets. It offers comfort and provides helmet structure. The visor will be made of Lexan polycarbonate, a clear, lightweight, yet strong material used on airplane windows, usually layered with a hole in the middle layer to release condensation. It can handle temperatures up to 240 degrees Fahrenheit, has a density of 1.20 grams per cubic centimeter.
We can add a layer of Kapton over the visor. Kapton is a polyamide film made by DuPont in the 1960s and is stable at a wide temperature range from negative 452 degrees Fahrenheit to 752 degrees Fahrenheit. It blocks more radiation and adds reflective properties.
There should be vents in the back to help regulate output of carbon dioxide and moisture and input of oxygen.
We also wanted to include water, which is a hydrogen-based material inside our polyethylene or silicone rubber layer. But we learned from nuclearconnect.org that the water needs to be 13.8 feet thick in order to be an effective radiation shield.
We appreciate NASA for allowing our students to participate in the Moon to Mars mission. The project has been fun and challenging for our students and for the teachers as well. We have learned a lot as we have teamed up with our students.
Thank you for considering our Central Space Station team for our upcoming journey to Langley Research Center.
We are the Central Space Station team. Central Bulldogs are out of this world.